Good morning, good afternoon, good evening, whenever you're listening to this. Welcome back to Igniting Young Minds, Developing Critical Thinking Skills in the Primary Classroom. I'm so excited to be back here again to talk to you about logic. If you've been following along in this series, I have developed a framework and we are going through the different pieces of the framework to have a better understanding of each piece and how those pieces come together to build a framework of critical thinking skills that will really help primary teachers to, first of all, understand what critical thinking skills are, what they look like in younger learners, and how to develop them in the classroom. And also some reflection questions to help teachers know if it actually is developing within their students. So we went through open-mindedness and self-regulation as the foundational blocks that really build critical thinking. And then we moved through observation and analysis through to logical reasoning. And logical reasoning is in this three parts. We talked about interpretation and inference. And now we want to talk today about pure logic. So logic helps us decide whether our conclusions actually follow from what we know. So as teachers, we're constantly giving out information and we're asking our students to think about what we've said and to come up with conclusions based on information that they have. So logic is how we actually figure out what is true and what is not true. It keeps the process of examining in a line. So the conclusion follows from the information that we're using. And what is a little bit tricky about logic is that you have to prepare the evidence. So all of the information that you're using to come up with your conclusion has to be present in order for that conclusion to be proven. Sometimes you can come up with correct conclusions without having all of the evidence that is necessary to actually prove it through logic. You can use inference. We talked about before interpretation and inference, and you can come up with conclusions with your experience and just applying knowledge. But unless you have what everybody considers to be reasonably true facts that follow each other, that is where we find true logic. And so math principles are based on logic, like 2 plus 2 always equals 4. When you have I have two fingers and then I have two more fingers and I put them together and I get 4 fingers. And if I didn't have 2 fingers over here, if I had 3 and I was calling it 2, then that's a problem with observing. Like I'm not giving the right information to get to my answer 4. I have to have only 2 plus 2 is 4. If this turns into 3, then the answer changes. So anytime you change the beginning information, the conclusion will always change as well. So logic does not create ideas. Logic evaluates ideas. So logic asks, does this conclusion actually fit the evidence? And so, like I said before, I'm going to give you an example in a minute about how you can come up with the right answer, but you came up with it because it's true, not because you used logic to get to it. So let's just think about logic versus inference again. Inference helps us reach conclusions based on, like we talked about last week, experience and prior knowledge. But logic helps us test those conclusions to make sure that those conclusions are actually correct. So remember, we said that all logic is inference, but not all inference is logic. So as we talked about interpretation and inference and this logic, they're all types of inference, but the logic that we're talking about today is coming up with a conclusion based on true premises. So inference can be quick and intuitive. We can move to our conclusion much more quickly when we're using knowledge that's already in our brain or our past experience. Using logic is slower and it's more deliberate. We need to test the information. So when I think back to my experience, I need to test that experience with other people's experience and understand, is that really true? And then if I can come to the truth of the initial premise, I can use that information to come to a conclusion. So sometimes it can be a little bit difficult or threatening because sometimes it's taught as right versus wrong. Sometimes it's confused with being argumentative, but that doesn't make any sense because this is not evidence to come to that conclusion. And sometimes people use logic to shut down discussion instead of deepening it. So for example, as teachers or students are just learning to think. They're just learning to process information and understand logical progressions of how you come to conclusions. So in a classroom, you might be giving out multiple pieces of information, and in their weakened state of being able to properly process that information, they might come up with a conclusion that is just not logical. And then so you say, oh, well, that's not logical, and you move on without truly understanding how that student got to that answer. So just as in inference, when we're dealing with our students, we need to be really cautious and careful in how we're responding to students who are actually making efforts to engage in our lesson. We need to follow their thinking, because if one student is thinking, the loud one is thinking this way, there's probably quiet ones in your class that are also thinking the same way. So it's really important that we draw out from our students what their evidence is and how they came to that conclusion. And then you can point out where their logic was off. So we really need to be using logic to open thinking instead of closing it. That's why it's really, really important in the classroom to be able to teach logic in such a way that it helps students to grow in their thinking. So I just want to use a couple of examples that I made a graphic of. All dogs have 4 legs. Spot is a dog. So therefore, using that logic, so the premise that all dogs have 4 legs and that Spot is a dog, those two things are true. So we can logically conclude that Spot has 4 legs. So all dogs have 4 legs, Spot is a dog, so therefore Spot has 4 legs. But if we say that all dogs have 4 legs, Spot has 4 legs, we can't automatically assume that Spot is a dog, because there are other animals that also have 4 legs. So when we're looking at the information, we have to follow the steps to get to the conclusion. So just in the same way that 5 plus 2 equals 7, we know that 5 plus 7 does not equal 2. So it's the same fallacy in the second 2 arguments. So let's talk about another example. All birds have feathers. A parrot is a bird. Those are 2 true facts. All birds have feathers. A parrot is a bird. So we can logically conclude that a parrot has feathers. Now on the other side, all birds have feathers. A parrot has feathers. Can we logically conclude from those 2 pieces of information that a parrot is a bird? No. We do know that a parrot is a bird. but not from those two pieces of information. We cannot logically conclude that a parrot is a bird from those two pieces. We would need to add more information that all living animals with feathers are birds. And then if we said a parrot has feathers, then we can say a parrot is a bird. So as you can see, that this needs deliberate thought and deliberate processing, especially with our young learners. And so there are easy examples like this that children can understand. And you can use these kind of examples as warmers in your lessons to just anytime you have pieces of information that you can make connections really easily, that children of at lower developmental stages, age-wise, if they can understand that within your lesson, if you are learning about a topic where you can find a specific logical example, then you point it out and say, this is true and this is true. So what can we determine from that? And you can use these examples over and over again so that this children start thinking in logical terms. Now, logical thinking is something that definitely needs to be developed over time, but also it's from your frontal cortex, which studies have shown that the frontal cortex doesn't even really start working until age 7 or 8. That's not exactly true, but in terms of logical reasoning and some of these higher thinking skills, children cannot even access that kind of thinking until their brain is functioning at that level. Up until those ages 6, 7, 8, children are mostly working from their emotional side. So as we are working with children, depending on their age, we really need to understand that as we are adding logic to our lesson plans, we need to understand that it takes physical neural pathways to develop in the brain in order for logical reasoning to actually happen. And so we need to have incredible patience and incredible breaking ability to break down arguments into these small pieces so that children can start learning it very early. So one of the things that we really need to be aware of in the classroom, like we talked about, is how we're responding to children in terms of what we know is logical. We need to understand that the children don't know that that's logical. Secondly, we need to notice the information that is missing, because sometimes children are coming up with conclusions and they're giving out information without having all of the information that they need to come up with the right conclusion. So sometimes conclusions are too big for the evidence that we have available. So either you say, this is what we can think based on this information, but really we need this and this and this to add to it in order to come up with a better conclusion. So one of the things that you can do to help your students is you can use data that you've collected or that you have available and compare different conclusions that you can come to from the same data. And then you can use logic to discover which pieces of evidence lead to the correct conclusion. So you can ask students on a regular basis about conclusions following from what we know. Does this conclusion that you just made follow from what we have learned or what you know? And what is the evidence that supports your idea? Is there anything missing? Is there any knowledge or information that you need to make a better argument? So this is really about curiosity, building curiosity in our kids and not correction, allowing our kids to say what they think, and understand that their thinking is not going to be correct, but it's a process of growing and learning. And the more mistakes they make, the better they are going to be at developing the skills that they need to be able to be great thinkers in the future. So, just some reflection questions that you can be asking yourself. How are you allowing your kids to process information? Are you shutting kids down because they are giving illogical answers? Or are you drawing out their thinking so that they can understand the process of thinking? Are you modeling logical thinking, or are you just expecting it to happen? Are you breaking down information into logical pieces to make it easy for your students to come to logical conclusions? Do your students feel safe to change their minds? Once they have given an answer, are they able to reprocess that information and feel safe to give a new conclusion based on the new information that they processed? So these are some of the ways that we can really encourage our students to develop the skills and give them the safe environment to be wrong, to make wrong conclusions, and to be illogical. The more we're illogical and given the proper information, the more we can change and turn, allow our students to make that leap from illogical reasoning to logical reasoning. So next week, we are going to move into decision making. And this is the next step in the framework. We've observed, we've analyzed, and we've gone through the processes of logical reasoning so that we can now come to the place where we take those conclusions that we've come to and we make decisions. We move forward in the process of creating or problem solving or whatever the project ahead is. We need to be able to make decisions. So next week, we're going to talk about decisions. I look forward to seeing you, and have a great week, and we'll catch up next week. Take care. Bye.